Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to multiply the 5 by the 2 to remove it. You're going to do x squared minus 3x minus 10, and then you're going to have 5x minus 5 and 5x plus 2. From there, you're going to reduce the first one, so you're going to have x minus 1 and 5x plus 2 for your final answer. Okay, for the math knowledge question, we want to know the overall test score. So this teacher deletes the lowest test score and averages the remaining ones. So the lowest one that he made was a 62. So you're going to add 78 plus 83 plus 86 plus 93. And then you're going to divide by 4 instead of 5 because we only have 4 tests now. And that's going to give you an 85 average. So D would be your answer. So we're looking at lesson 40 today. Units for the derivative, normal lines, and then max and min on a graphing calculator. So hopefully after we finish this lesson, you'll understand units for the derivative, normal lines, and max and mins on a calculator. So the unit for the derivative of a function is the unit of the dependent variable, whatever's on your vertical axis, divided by the unit of the independent variable, whatever is on the horizontal axis. So looking here, the distance s of the particle is given by the equation s equals t squared plus 3t plus 7, where s is in meters and the time is in minutes. What is the rate of change of the distance with respect to time when time equals 4? So anytime you see rate of change, that is talking about the derivative. So it says, what is the rate of change? That is, what is the derivative with respect to time when time equals 4? So basically, what is the derivative of the distance? So our distance formula's derivative is going to be 2t plus 3. And then we want to know when t equals 4. So we're just going to plug in 4. So 2 times 4 plus 3, that would be 11. And so that would be your rate of change when t equals 4. And the units, we want to know the rate of change. The units would be meters, because it says it's in meters, per minute, because it says it's in minutes. 11 meters per minute. Okay, looking at another one. For the velocity is given by 4t squared plus 2t plus 4. What is the acceleration of the particle when t equals 3? So we are looking for acceleration. Now, you may not be aware, so I'm going to go over this. If you've taken physics, then you may already know this. If you haven't taken physics, then you may or may not know it. Position, the derivative of it is velocity. The derivative of velocity is acceleration. That is something that you're going to want to know. You're going to want to know that the derivative of position is velocity, and the derivative of velocity is acceleration. So it says, what is the acceleration? Well, that's the derivative of our velocity. So the derivative of the velocity is going to be 8t plus 2. And it says t equals 3. So we plug in 3, and that gives you 26. Now, velocity's units, it said, was meters per second. And then acceleration is in seconds. So meters per second divided by second. Well, meters per second, instead of dividing by second, we can multiply by 1 over second. And so that gives you 26 meters per second squared for your answer. And so you don't have to go through all of that work every time. You can just remember that acceleration, if it's in meters and seconds, acceleration is meters per second squared, or miles per hour squared. It's always going to be a time squared. So that's how the unit for acceleration works. So now we're going to move on to normal lines. In math, the word normal doesn't mean ordinary. It means perpendicular. So we've talked about tangent lines already. Normal lines are very similar to tangent lines, except for that they are perpendicular. So when you're looking for a normal line, you're going to do a lot of the same stuff as what you did for finding a tangent line. So we want to find the equation of the line normal to the graph of y equals e to the x at x equals 1. So the first thing we have to do is find our slope. And our slope is found from our derivative. So the derivative of e to the x is e to the x. And then we need to evaluate it at x equals 1. So our slope is going to be e to the 1, which is just e. However, we're looking for the normal line. Normal means perpendicular. So the perpendicular slope is the negative reciprocal of e, which is negative 1 over e. So we're going to use this slope to find our normal line. So we're going to use y equals mx plus b. So if our x value is 1, we can plug it in to find our y value, and our y value would also just equal e to the 1, which is e. So we can say e equals negative 1 over e times 1 plus b. So e equals negative 1 over e plus b. So that means that b is e plus 1 over e, which you can make as one fraction with a common denominator of e. And so it would be e squared plus 1. So then your equation would be y equals, our slope is 1 over e, x, and then plus e squared plus 1 over e. And that would be your answer. Okay? So that's how you deal with normal lines. Very similar to a tangent line, but you have to remember to find this perpendicular slope. So now we're going to use a calculator as necessary to approximate the equation of the normal line to y equals e to the x when x equals 2.7. So first off on this, the derivative, to be able to find that, we're going to need to do a little bit of u substitution here. So we're going to say that y equals e to the u, and let u equal sine of x. So if y equals e to the u, the derivative of e to the u is e to the u, but we have to take the differential so that we don't forget about our du. And so then our du, the derivative of sine is cosine, and then dx. And so if we substitute, we would get e to the sine x, and then cosine of x dx, which this is our dy, so we can divide by dx to make that go away. So our slope is given by e to the sine x cosine of x. And so we need to know what that slope is when x equals 2.7. So we're going to use our calculator. So we're going to do e to the sine of 2.7 and then times cosine of 2.7. And you need to make sure that you are in radians. And so that gives you a slope of negative 1.3862. But we're looking for the normal line. And so what does normal mean in math? It means perpendicular. So we need to find the negative reciprocal. So negative 1 over that number that we just got. And so our slope would be 0.7214. So that's the slope that we want to use. From here, we're going to go back and find our y value. So to find our y value, we're just going to do e to the sine of 2.7. So e to the sine of 2.7 gives you 1.5332. Okay. From there, we're going to plug it into y equals mx plus b. So 1.5332 equals 0.7214 times our x value of 2.7 plus b. So our b value, we're going to do 1.5 minus this 0.72 times 2.7 number. Uh-oh. And then you should get negative 0.4146 for your b value. So for your equation, you would write y equals 0.7214x minus 0.4146. And that would be your answer. Okay, so that's how normal lines work. Again, they're very similar to tangent lines. They are just slightly different because you have to do the perpendicular slope. All right, so now we're going to look at approximating maximums and minimums on the graphing calculator. So the way you're going to do that, we're going to need to be in radians for this one, so we already were. You're going to go to y equals. And you're going to plug in your equation, sine of x. And then you're going to go graph it. So there's the graph of y equals sine of x. And it wants to know where the maximum is in between 0 and pi. 0 is here. Pi is about 3.14, which is about right there. So we're looking for the maximum in between there, which is going to occur somewhere right here. So I think I discussed this several weeks ago towards the beginning of the year, just briefly. So I'm going to go over it as if I haven't talked about it, just in case you've forgotten about it. So you're going to go to calc, so you're going to do second trace, and we're going to do maximum, which is 4. And so we can actually type in 0 for our left bound, and then our right bound is going to be pi. And then you can guess that it's about right there. And it tells you it is exactly 1.5708. Well, approximately, because that's what it's rounded to. But that's what your calculator gives you for your maximum. So if you want to, you can estimate for your maximum and your minimum left and right side. You can do your left bound there and your right bound over there, and then you can guess something right here if you want to, and it'll still give you the same answer, or you can just plug in the 2 endpoints that they gave you. So either way will work for that. Okay. All right, so for this one, we want to again approximate using the calculator. So we're going to go back to y equals, and we're going to do x cubed plus 4x squared minus 7x minus 5. And you're going to graph it. And it wants to know where is the minimum between 0 and 4. Well, if you look, the minimum is going to occur somewhere over here. Because here's 0, 4 is over here. And this is the minimum. So again, we're going to go second trace, and we're going to pick minimum because it said find the minimum. So if you want to use your arrows, you can, or you can just do left bound of 0 and a right bound of 4. And I don't have to do a guess because there's only 1 in between there. But if you do, guess that you should get it close, kind of close to here. And so our minimum occurs at 0.6943. and negative 7.597.2. And so there's your minimum point. So that would be how you would find your minimum point, and the value of the minimum is your y value. So negative 7.5972. For the last example, it asked for the maximum value, and I'm just realizing I gave just the x value. The y value was a 1, and so if we're looking for the max value, it'd be a 1. But I prefer if you put the point, the whole thing, rather than just one value. So you would put 1.5, comma 1, and then 0.6, comma negative 7.5 for your answer for those. So that's how you use your graphing calculator to find max and mins. They're not difficult. They're kind of like finding zeros. You just have to get to the left and right of them and then guess pretty close. So your homework is 1 through 25, so make sure that you do that tonight so that we can go over any questions that you have tomorrow.